Hey guys, so I'm going to go over our last lesson in chapter 4, which is on combinations. And with combinations, again, you will need your scientific calculator. And instead of looking for the NPR button like we did in the last lesson for permutations, we're actually going to look for the combinations button. And the combinations button should be relatively in the same area as your calculator. So again, for my Casio FX300 ES Plus, it is just to the right, and it looks like this. So it looks like subscript N combination R. Okay, so it looks like that. That's the button you should be looking for on your calculator. And I'm going to basically just start the lesson by discussing how combinations is a different process from permutations. So just doing a little comparison that way. And then I'll work through some examples where you actually work through typing in a combination example into your calculator, so just learning how to maneuver and evaluate effectively, and then we'll do a couple word problems. Okay, so here we go. So we'll consider this situation. So there are 31 students in our class, so as you know from the very beginning, there is always a big group, and if every student shook each other's hand once, how many different handshakes would take place? Okay, so basically in considering this, we have 31 students, and because there's 31 students, we would actually be only making, though, 30 handshakes, right? Because we wouldn't be handshaking twice to the person who I'm handshaking with, right? So for instance, if I'm handshaking with Emmanuel, and then Emmanuel handshakes back with me, we have two arrangements within our pair that include the same people. Okay, so I'll let you guess what you think the value would be. So you can pause the video, think for a sec. How many handshakes would actually occur in this scenario? And then, because the handshake between each pair occurs twice, this is how we would actually solve through it. Okay, so the number of handshakes is equal to 31 possibilities with 2 arrangements within each pair that include the same people. Okay, so I'll work through what this would look like in terms of looking at your formula, but basically what we would do in our calculator, you would hit the number 31, shift NCR 2. Okay, and that actually will represent how many different handshake combinations there would be in our classroom. Okay, so what changes basically between the idea of permutations and looking at combinations? So permutations was our last lesson in 4.8. They're ordered sets where ABC, BCA, CAB are all different possibilities because one permutation order matters, right? So we always discuss the order of it does actually matter in terms of are we starting with child A? Are we starting with child B? Are we starting with child C like we used in our initial example? However, for many counting problems, order is not important. Okay, so order actually does not matter. And in the combination example I did with our handshakes, this is what really happened. So the way in which people shook their hands, right? So whether we took the first person in the front of the class with the back of the class, or the actual I guess combination of people shaking hands wasn't really what mattered. What mattered was that there was 2 people or a pair of people that would then, if we counted, would have shook each other's hand twice. Okay, that's more so what we focused on. So combinations are unordered sets where ABC, BCA, CAB, etc. are considered the same, because with combination orders, it does not matter. Okay, so we see here what we did in 4.8, and this is going to be for 4.9. So we can see for permutations, that was the formula we used in our last setting, where order was something to consider, right? So even going back to the vice president and president selection, right? Order mattered because once you chose the selection for president, you only had then one less opportunities from the original nominees to elect for vice presidency. Okay, and then for today we're going to work on 4-9, where this is the combination formula we're going to use, and again considering when combinations for order that does not necessarily matter. Okay, so here we go. What I'd like you to do in your calculator, just for this first little set, is we're just going to practice and go through, again, how to evaluate. Okay, so if we were actually using the formula from the above section, right, this would be like 12 factorial divided by 12 minus 4, which would be 8 factorial, and then r factorial would be 4 factorial. Okay, so if you want to try that in your calculator, you can do that as well. If we were doing this again with the NCR button, you would hit 12, Shift, NCR, 4. Okay, and you should get, so 12, C4, that's just another way of writing it, should be 495. Okay, so if you want to pause the video, try a couple of these out. But these are the values you should be getting when trying to figure out the combination just working on your calculator. Okay. So please let me know if you have any issues at that point. But we can proceed for now. Okay. So we have here a Kenny bought 5 rose bushes. Guess I forgot an H there. We'll add an H, no problem. 3 pansies and 4 tulips from a nursery that has 15 rose bushes, 10 pansies, and 12 tulips. How many choices does he have? Okay, so what I'm going to do first, I'm just going to do a little color coding. Okay, so we got our 5 rose bushes with the H, and the nursery had 15 to choose from. Okay, so just thinking about what that would look like. Okay, so what he did then was out of 15, I can make that a little neater, he chose 5. Okay, we'll move on here. 3 pansies, he chose from 10. Okay, so it's 10, choose 3. Okay, and then last but not least, we can discuss the tulips. So 4 tulips from 12. 12, choose 4. Okay, so then essentially what you would do in your next step, you would have to figure out each combination, and to figure out how many choices that he has, you're actually going to take each combination and just multiply them. Okay, so we can start with the rose bushes. So again, 15, Shift, NCR, choose 5. So you get 3003. That represents your orange. Okay, and I'll just do the next couple for you, times 120 times 495. Okay, now your final answer at the very end, once you multiply them out, quite a big number here, 178,378,200. Okay, so with combinations, if we have multiple sets that we're considering, that's what we would definitely do to help figure out how many choices in total that he has. Okay? Okay, neat. All right, we'll move on to the next one. Okay, so the Yearbook Club consists of 5 girls and 5 boys. How many groups of 4 can be chosen if? Okay, so we have different scenarios for each one. Okay, so in total there are 10 members, and we want to figure out how many groups of 4 we can choose. So that would be 10 choose 4. So no restrictions, no problem, 210. Okay. So now we're going to consider a situation where there must be 3 boys. Okay, so now we know that there are 5 boys, and out of the 5 boys, we're choosing 3. Okay, now this is a 4 group member. 1, 2, 3, 4. So if these are all boys, our last slot has to belong to a girl. So now, out of the 5 girls, we need to choose 1. Okay, so essentially that's just 10 times 5, so we have 50. Okay. Maggie and Darren must be chosen in this situation. All right, so if they must be chosen, so out of our, so there's 10 members, okay? Now, out of those 10 members, if they have to be chosen, that's really 8, right? And then we're choosing 2. Okay, so once again, if we're considering that in the equation that we have been introduced to, okay, so there are 8 now that we're considering. Okay, we would then do 8 take away 2, which would be 6 factorial, and then r is represented by 2, and then 2 factorial. Okay, so 8 factorial over 6 factorial, 2 factorial. Okay, and then once you work that out, you should get 28. Okay, finding the probability of no boys. Okay, so in considering our probability, okay, something that we do know, we know when given no restrictions, it would be 210. Okay, when we find the probability, we got to consider, okay, no boys. So out of 5 boys, we'll consider how many groups of 4 can be chosen. So it would be 5 choose 4. Okay, but because it's no boys, it would be 5 choose 0. Okay, so this actually represents our girls. So out of the 5 girls, we have to choose 4. And then this represents the boys. Out of the 5 boys, we would choose none. Okay, so that would be like 5 times 1 is equal to 5. Okay, and then in finding our probability, okay, so I'll just move this over here. So our probability, there's 210 without restriction possibilities. Okay, so that's like our total. And then it would be 5 over 210. So that would be like 1 over 42. All right. Okay, we'll move on. We have 2 last examples just to consider. Okay, so we have our card set, so very typical in probability as you've probably seen. So how many distinct 5 cards can be dealt from an ordinary deck of cards? So again, 52 is our ordinary deck. We're choosing 5 out of that 52. So just plugging that into your calculator, working it out. Okay. All right, so one last question that deals with grouping. Okay, so a class consists of 10 boys and 8 girls. So I'll take out my highlighter, that's some good information. A group of 6 must be chosen to help with the school dance. And how many ways can the group be chosen if? Okay, so again, as a total, there's 18 members that I can choose from because 10 plus 8 is 18. And I must choose a group of 6. Okay, so 18,564. Okay, there must be exactly 2 girls. Okay, so out of our grouping, out of the 8 girls, there needs to be exactly 2, so I'm choosing 2. Now remember, we're making a group member of 6, so 1, 2, 3, 4, 5, 6. So if this is girl, girl, that means out of the 10 boys, 4 of them must be chosen here. Okay, so again, calculate each separately. You will get then 28 times 210, so 5,880. Okay, So you can even sense here that when we're trying to make our membership amongst girls and boys, you do have the opportunity to calculate them separately and then just multiplying those combinations. All right. There must be at least 2 girls. Okay, so this one's going to be interesting. Okay, so we can do this a couple ways. Okay, so we can first consider what the membership would be like if we considered 2 girls. What would it look like if we considered 3 girls as a combination, 4 girls as a combination, 5, and then 6 girls. Okay, so I'll do that way first. So what we'll do separately is we got to consider if there was 2 girls. Okay, so if there was 2 girls, so out of a membership of 8, we choose 2 girls. So that means out of the 10 boys, that will be 4 that's chosen. Okay, we'll consider what happens if there were 3 girls. So it would be 8 choose 3, and that gives me 3 spots for the boys. I'll consider if there's 4 girls. And again, the reason why I'm doing this is because of that word at least. So if it's at least, we have membership of 2 girls, 3 girls, 4 girls, 5 girls, or 6 girls. Okay. So with 4 girls, it would be 8 choose 4, meaning there's 2 spots open for the boys. Okay, 5 girls. So for 5 girls, that would be 8 choose 5, 10 choose 1, okay, and then if there were 6 girls, so if there were all 6 girls, then we wouldn't need to consider any boys. That would just be out of the 8 girls, I want you to choose 6. Okay. Now, in this case, yes, you are multiplying your choices with the girls and the boys, but because we want to find how many combinations they are with at least 2 girls, we're actually going to add up each sum. Okay, so then this should be 16,338 once you figure out each section. So there should be 1, 2, 3, 4, 5 sections, and then adding up those totals. Okay. You also could have done it this way. So if there needs to be, I'll put versus. So this is another method. You might like this way as well. If there needs to be at least 1, 2, 3, 4, 5, 6. So 2 girls are necessary, and we consider what happens if there's 3, 4, 5, and 6. You can also take away the options. So when there's 1 girl, isn't what we're looking for. And we're not looking for when it's 0 girls either. So something we can do, we can actually just consider what happens with our total. Okay, so total would be out of the 18 members, 6 girls, 6 members need to be chosen. Out of the 18 members, 6 members need to be chosen. We're going to subtract the probability of what happens when there's 0 girls, and also subtract the probability of what happens when there's 1 girl. Okay, and what's left behind will then be the answer that we're looking for, because then what's left behind are all the other combinations. So 2 girls, 3 girls, 4 girls, 5 girls, and 6 girls, right? That's going to be what's left over if I subtract the total minus the 2 situations that we don't want. Okay, so we'll go from here. So if there are 8 girls and I choose no girls, that means that out of the 10 boys, they will all be boys that I'm choosing. And then if I'm having an opportunity where there's 1 girl, out of the 8 girls, there will be 1 that I'm choosing. So meaning out of the 10 boys, there will be 5 that I will choose. once you work this out, this also gives you the solution of 16,338. Okay, so either way works. Just showing you some options. Okay, now we'll do the last question. So find the probability of at least 2 girls. So we just did this work, right? Twice actually. We got 16,338. We're going to divide it by our no restriction answer. So 18,564. And again, that will just simplify to 389 over 442. If you wanted a percentage, that would be about 88%. Okay, so again, combinations, as you can see, the ordering did not matter. What was more of a focus was just considering situations of, including whether it was girls from boys, looking at different ways that you can arrange a card deck, flowers from nursery, and so forth. Okay, so this is